So in this lecture, we are going to learn about different rules and guidelines that are usually followed while creating a 2D mesh. And these guidelines are always followed in the industries, and it is very important to understand the meaning of these guidelines and why they are useful. So in the first meshing guideline, here you can see in this case we have a converging or diverging body. Here you can see length on the left side is larger as compared to the right side. So in this case, when you generate mesh using the mixed mesh, this mixed and quad mesh, here you can see we have a combination of tria and quad, and we have only quad mesh. And what difference you will see here is in the left side the flow of mesh is very good, while in the right side the flow of mesh is not a good mesh. So that is why we always have to use mixed type of element, and our mesh flow should be like this. So we have to follow this, not this. So whenever you are going to mesh using the triangular element, for example in case of tetra mesh, whenever you want to generate a 3D mesh, in that case you have two type of element. One is simple triangular element. So these elements are in triangular shape. Another one we have the R tria. We have a shape like this, 90-degree angle. So usually simple triangular element are used in a planar face or faces that are planar in shape, while in case of fillets or any feature we use R tria type of element. Here you can see these are R tria. The reason we choose R tria here because it creates a very good mesh flow, and the reason we take the planar face for the equilateral, because in this type of triangular you can see these are equilateral triangle, means all the angles are 60 degree, and this is the ideal shape of a triangular element. When you do the 2D mixed mesh, you have to make sure that back-to-back trias should be avoided. Two tria elements should not be connected to each other directly. Consider this case. You can see we have two trias, this one and this one. These are back-to-back. Similarly this one. We have to avoid back-to-back trias. Similarly here this tria and this tria, these are coming back to back. We always have to avoid trias that are directly connected or back to back with respect to each other. Then in case of a planar face, we have to avoid the opposite trias or trias that are facing each other. For example, in this case you can see this is a tria element in this direction and this is in this direction. These are opposite trias and they will cancel each other to make quad element. So we have to avoid them. So this is not recommended. Similarly here you can see two tria are facing each other. This is also not recommended. When you remesh them, you will get a proper quad element. So that is something recommended. Means opposite tria or tria facing each other are not recommended and we have to avoid them. And generating a good mesh on the fillet or any radius or any curvature is very important, because these are critical area where there are maximum chance of failure. So there should be no mesh transition on a radius. Here you can see currently two layers of elements are coming, but suddenly it has come to one layer. Now here you can see only one layer. This is something not recommended. Also here you can see the flow of mesh is not good here. This is something not recommended. Now we have to avoid tria on the outer edge or hole. So let's say this is the boundary of the surface, outer boundary. We have to avoid tria on the outer boundary. Also we have to avoid tria closer to any hole. Here you can see this is something we have to avoid. Here you can see we have two examples of mesh. This is, let's say, mesh number 1, mesh number 2. The difference you will see here is, here you can see there is not a proper flow of mesh on this area also. But if you take a look at the second example here, you can see the mesh flow is very good. Here you can see the mesh is flowing like this, similarly flowing like this. On the circular region you can see washer has been created here, but here you can see there is no washer. So overall this is a type of mesh that is recommended, and we have to avoid such type of meshing here. Whenever we have any circular hole or hole for the bolt connection, we have to mesh it using a washer. So washer is basically another circle with some predefined diameter or radius. Usually the recommend is that there should be at least minimum 2 layers. Sometimes we can take 1 layer, but at least 1 layer is recommended. While some companies also prefer 2 layers of element. Here you can see we have a hole here. So this is the hole. Then around this hole you can see a washer has been created. Similarly washer number 2, washer number 3. Generally these washers are of value d/3 dia. So we take dia of this hole and then we add d/3 value to this. Again, in some companies this value may change. Sometimes it is 1.5 or 2 times the diameter. Also we have to make sure the number of elements should be always even. So even number of elements are always recommended and odd numbers are not recommended when you create a mesh around a washer. Another thing is node should be properly lie on a surface with no deviation. Here you can see this node is going away from this surface. This is something not recommended. The nodes should always be projected properly on the surface. It should not deviate away from the surface, because the element or nodes represent the geometry in FEA. So if any node is deviating away from the surface, it means the software will create a distorted type of geometry. In the similar way as previously discussed surface, the node should be properly lie on the edges, or node should follow the feature line properly. Here you can see in this example, this is a feature line that we see in the CAD geometry, and while these are the nodes, you can see these nodes are not properly projected on these lines. This is something not recommended. The node should be properly projected. For example, in this case you can see this is a feature line and nodes are properly projected here. Okay, but again these nodes are not projected, so again we have to project them onto this line properly. Now this is again the concept of following a smooth mesh, that we have to avoid zigzag type of distribution. In that case we have to use a smooth mesh flow. Here you can see we have a mesh that is a quad mesh, but again here you can see the mesh flow is not good. Mesh is going like here, so it is a zigzag meshing. This is something not recommended. We always have to create a mesh that is a well structured or smooth mesh. After that, whenever we perform analysis for a specialized type of analysis, for example in case of crash, rotating quads are not allowed. Here you can see this mesh is coming here, then you will see a rotating quad. This is something not recommended. Again here in this example we can see rotating quad. So generally in structural analysis we can use them, but in crash we cannot. We have to follow a smooth mesh transition. Here you can see the smooth mesh transition can be used followed by using the tria element. So here you can see tria elements are used. This is something that is recommended. Now many times the students make mistake here is when you perform meshing of such type of geometry, or whenever we have a curvature. Here you can see the geometry is diverging. Here the length is more, but here length is very less. and here is a transition phase. Many students make mistake here is they make mesh like this. This mesh is going here, going here, going here. Here you can see it is following a proper smooth lining curve, but this is something not recommended. The reason here is that it is a variable mesh size. Here you can see the size of mesh is much more, but here it is very small in the rightward side. Here you can see it is a very small mesh. So meshing size should always be proper. So that is why it is recommended to insert tria element in such type of cases to have a proper meshing size. Another thing is when you create mesh of let's say two surfaces, the mesh should be properly connected. Here you can see in this example we have a mesh on the left side, mesh on the right side, but here you can see this mesh is not connected properly, here in this case, here in this case. So our mesh should be properly connected and there should be no free edge. So whenever mesh is not connected, it is called free edge. There should be no free edge into the meshing. So these are some of the guidelines that are followed in the industries to have a good mesh.